Hi, I'm RC Jim, and we're in the process of getting this very beautiful red-tail P-51 all fixed up after a very major crash. And of course what we're into right now is getting the engine mounted on the front. We've just had a video on restoring the fuselage, which has come along very nice, and before that repairing the fiberglass nose cone. But right now, as we think about the power, anytime you are setting up a plane that you haven't bought from the factory with everything included in it, if you're adding the components yourself or you've gotten it from somebody else, and who knows where they've gotten the components from, you want to make sure you've got a few things right. Now, naturally, in this particular case, we've got the motor determined. So it's a Dualsky XM5050-EA-12, 610 kV. And a natural thing that you'd do is you'd go onto the internet and you would find the schedule that tells you whatever you can know about it. Oftentimes, all they're going to tell you is a recommended prop and recommended ESC and maximum burst amps, and they might tell you maximum continuous amps. But you get whatever information you can. In this particular case, they've told me that the maximum burst amps is 70 amps. They've given me the maximum efficiency amps, but the maximum efficiency isn't really a safety issue. That's more, if you want to get the maximum endurance out of the plane, you'd run it like at 35 amps in this particular case. But we're not particularly worried about that one. But we don't want the thing to melt down. So the burst amps is really important. If they had a maximum continuous amps, we'd love to know that. They just simply haven't told us that. But they've suggested 100 amp ESC, and I note that this plane, when we first flew it, we had a situation where it nosed over into the ground as I was giving it the throttle, and I cooked the ESC. And that's likely because they had the helicopter setting on it for maintaining the RPMs instead of just applying a certain amount of power. But nonetheless, we melted the ESC, and when I flew it the second day, when we had the horrible crash, I had just stuck another ESC in that I had, was a 65 amp. Well, 65 amp, when you got a 70 amp burst, you probably get away with it, but I feel better to have a 100 amp ESC. So what I've done is I thought, well, let's see what we could do on a real inexpensive basis. And so we've got this one that is made by V-Good, a Chinese company, and this was really cheap. And so I thought, well, hey, why spend $100 or whatever on an ESC when I can get one for, I don't know, $30 or something like that, 100 amp ESC. And yeah, so let's see what we can get this thing to do. So I'm going to do the testing with this. I've also managed to find a programming card for this one, which is really hard to find. Ended up shipping it in from America. Hopefully the factory gets going again and they start producing them. But nonetheless, I got a hold of one, and so we'll go through the programming card as well as what you can do with it. And we'll do some testing with different props and make sure we've got a suitable setup for our plane. One less thing to have to worry about. So let's get right into it. Well, I'm preparing to solder up the connectors for our 100 amp ESC, but I discovered I got a problem. Okay, this just goes to show that we need to be pretty careful when we go to purchase things to make sure we've got the right thing. These things look pretty well identical. They're the same size as far as fitting into the male banana plug, and that looks like that's the same size, but when I go to put a wire in it, that one gets in with a lot of slop, and this one it doesn't fit. Okay, so I happen to have 3 of these. I probably bought these from a hobby shop, and these guys I got from some Chinese thing online. But that's going to work. What I was about to do, had that not worked, was to go up to the next size. And with that, I'd have to replace the banana plugs on the motor, as well as the put the ones on the ESC. But it looks like I don't have to do that because I think I've got 1, 2, 3 of these ones that ought to work. So we'll give those a try. Well, we've now soldered on our connectors. We got the XT90 male, and that end of the ESC. We got 3 different colors of these banana plugs on this end. Actually, it looks like that one could get shrunk a little bit farther. Yeah, them all shrunk down nicely. I try to keep a little bit extra on the ends of these, just to avoid any metal that might be showing on the end. So we've managed to get those all to where when you look sideways at it, there's no metal showing. This one's got a little bit extra heat shrink sticking out. That one's just a very tiny bit. That's a very tiny bit. But those will work out well. And of course we've got 3 different colors so that if the motor is going backwards, to exchange 2 of them, and the colors will help you sort that out. So those plugged in there, I can't see hardly any metal. See a tiny bit on the black one, nothing on the other 2. But that's going to be pretty good. And they all fit, and I didn't have to replace the connectors on the motor. So I'm happy with that. Okay, some of you have seen this before, but this is our setup for as far as the test rig goes. So we've got our battery, the ESC. We've got a watt meter that's going between the battery and the ESC, so you can measure the watts and amps and so forth. We're using a battery capacity meter. This is a GT power version, and by holding down the cell servo button here, it allows it to simulate a servo, so I can just simply dial up on the thing here. That brake is on. That's interesting. I thought we had the brake off. Okay, we will check that in a minute. But anyway, for our purposes right now, it doesn't hurt to have the brake on. Okay, so what we want to do is we are keeping track of which prop that we've got on there. Right now we got a 13x6 Windsor prop on there, and we're going to see at maximum throttle what the amps are, and we will have a look at what the thrust is. We got the little scale on the back. Okay, I've just checked the battery here with our tester. It's on 98%, and so I'm going to jot that down. We make sure our wheel is down all the way so that the throttle is going to be off when we start it up. We hook up our power. Okay, and we have to get this plugged in. Right now that little signal, the sound, is telling you there's no throttle hooked up. So you hold down the cell button. That then shows 1,000, so that indicates the throttle level. We want this to be zeroed out, so make sure that that's not pulling on it. And we are all set to go. So we turn on our scale. Boy, that thing pulls. 87 amps. That's too high. 87 amps and 35 grams of thrust, so 5.5 kilos. Boy, that is massive. It actually got up to 92 amps according to that. Okay, so that prop is too much. We need to back off. Well, I'm a bit surprised at that result, in that when I look at the data sheet, it tells me that a 13x5 or a 14x6 ought to be fine. And this is a 13x6 with the electric version. It's a Windsor master air screw, and it ought to do the job. But while the spec sheet is telling me that that would go up to, I guess it does say that would be up to 80 amps.
course, we've gone up over 90, so that's a particular problem. So we're going to back off a notch, and I don't have a 12 by 6 electric version, but I do have a 12 by 6 in the K series, the one that you would use with a glow fuel engine. So we've got that one on now, and we'll check that one out and see how it goes. So we've got our test rig all set up, and everything likes to blow away with us. You know, we've got nice powerful engines that really produce a lot of prop wash. So taping down a few things that weren't taped down before, just so we don't lose any of those. And you notice a nice little clamp on my little notebook over there. So I think we are about ready to go. This test was with a 12 by 6 Master Air Screw K series. Our battery is 24.4 volts, and all set to rock and roll. As we ran the test, we came up with 61 amps, and then when we went back and looked for the peak of the amps during the test, it actually was 64.7 amps. So we are under our 70 amp burst, and so that's good. And the thrust came out at 4240 grams, 4.24 kilos of thrust. And so that's going to be quite suitable for a model that we expect to be a little over 3 kilos in weight. So this appears to be a very good combination to use, the 12 by 6 Master Air Screw K series. I might mention that in order to work out the flight time, I backed off the throttle to just under 2 kilos of thrust, and it was drawing 19 amps. So at 20 amps, if you got a 4,000 milliamp hour battery, that's 4 amp hours divided by 20 amps times 60 minutes per hour. That gives you a 12-minute flight time. Now that would be being rather leisurely with it. If you really want to hit it hard, it's going to be less than that, but it'll give you a good idea of what to expect. Okay, well, now I know which prop I need to use with my Dualsky XM5050. And of course you know what sort of things that you need to go through to work out what you need for your particular motor. What I didn't do was get into the programming card for the VGood ESC. I'm going to do that in a separate video, just realizing many of you will have different ESCs than that. But for those that have an interest in a very low-cost ESC, you probably want to have a look at it. Well, I'm RC Jim. It's been great to be able to share this time with you. Make sure that you subscribe. Yeah, just click on that little circle with my picture on it there. And it doesn't cost you anything, and that keeps all of this stuff very handy for you and all of the new stuff that's coming along. And then also have a look at some of our other videos on the channel. I trust that you'll find them very helpful. Well, you have a great day and happy flying.